Now, I want to talk a little bit about the trap that is very easy to fall into. This here is a soft foot problem, and a soft foot literally is, let me give you an example. Let me grab this chair. A bit of crack, some soft foot problem. That's okay, I've got this thing here. Okay, soft foot. Now, if I have that soft foot problem on a new machine and I don't do anything about it, simply install the machine on its base and then bolt that machine down without removing the soft foot, I'm going to cause a banana of that machine body, and all the parts and bearings and shafts and components inside, they're going to be under stress. They're going to be distorted, and that's the brand new machine. Brand new machine with a soft foot problem. Internally, my parts are already under high stress and the machine hasn't even been used yet. And if I use the machine when the parts are under high stress and they're banana shaped or they're squashed together very hard, they're not going to last very long. You know, press the button, the machine will go. It'll just fail in a matter of months when it should have been many, many years trouble-free operation. So if I have soft foot, you know, I can solve it. I solve soft foot by putting a shim. You know, put a shim there, problem gone away. So yeah, we can fix that problem. Soft foot is something that certainly is solvable. The hassle is we then give ourselves a reliability problem for the remaining life of this equipment. What I've done here, this is our foot, our machine foot that's part of our assembled machine. If it was perfect, if that base plate was perfectly flat and the feet were perfectly sitting on that machine, as we can make that level of accuracy, this holding down process, this holding down system would involve the bolt head, the machine foot itself, the shank going through, some sort of threading connection on the frame itself, and then of course the frame. There'd be a 5-step holding down process. But of course we've got a soft foot problem. So I shim up the soft foot. Soft foot problem goes away, the machine is now not being deformed. But I now have got a 10-step holding down process. This person's put in 5 shims. I have got 5 more things to go wrong in the future of this company. So this brand new machine that will be there now for 50 years or 25 years, whatever the case is, I have given ourselves 5 more opportunities for this to go wrong at any point in time. So whenever this machine's maintained by my guys, whenever we take that machine out of place to do some sort of maintenance, if the guys only put back 4 shims, because the technician thinks, well, I pulled shims out, I put shims in. So up here in his mind, it's okay. He's put shims back where they belonged. But if one falls in the dirt or one's lost somewhere and nobody replaces it, now 4 shims go back. In their mind, it's all okay because shims came out, shims go back in, except now I've got a soft foot problem that no one's recognised because nobody's thought it could happen. And so, yes, we can fix defects, but in fixing defects, we give ourselves years of trouble. Forevermore, we'll have trouble. Now, I'm 56. When I was 54, I learnt something. It turns out that when you start putting shims together, when you start putting a stack of shims together, especially when you put a stack of 5 shims together, when I've got a stack of shims, I've got many faces. And at each face, over time, that face relaxes. And so that initial tension I had on there, in the next few weeks, next few months, that tension relaxes right off because the faces, the surface of each face, slackens and the tension disappears. So in a matter of weeks, this fastened up hold-down bolt will actually be loose because I've got too many shims in here. And each shim face becomes a place to reduce that tension. So if I'm going to start using shims, I've got to ask the question. 5 shims is too much. 5 shims means I will create a loose connection in about the next few weeks. It'll start to go loose because the metallic nature of our shim material the spring basically slackens off. So 5 shims are too many. How many is acceptable? So this particular presentation, we discussed that, and the group began to talk about what they do in their companies. The perfect solution, if you're going to have a shim, then 1 shim is perfect. That's the best we can achieve if we're going to have a shim. But that means you have to get a perfectly sized shim, which is very unlikely in most general situations. So now 2 becomes a possibility, because with 2 I can play with the size of the shims that I can use. That, from what the guys were telling me in the conversation, is also a hard thing to get right on a regular basis. So eventually we settled on 3 as the maximum number of shims to use, to not have as big a problem with slackening of faces, but it doesn't actually prevent the reliability issues in the years to come. So yeah, we can solve our problems, but we don't then increase reliability. We actually decrease reliability of the equipment. Now, the other issue too is sometimes you see the guys put a number of washers underneath bolt heads, and you start to make up the gap, to make up the space. They'll put a number of washers. Same story. When you start putting multiple washers, you've got multiple faces. So you must eventually have a loose connection. So if you're going to start using shims, to protect against loose connections that you will surely have, because the process you've chosen must lead to loose fasteners, you've got to add one more process on top of that. On a regular basis across your whole company, you'll have to go and tighten up every hold-down bolt to make sure that ones with shims have not slackened off. So if I start using shims, I'm going to then add in a regular tightening process of every bolt that has a shim under it. Otherwise, in time, these hold-down bolts will come loose. The machine starts vibrating, it gets bigger and bigger, and the bearings inside start being knocked about, and I have a breakdown. So yeah, this is the worry with accepting defects. And the whole issue is we can make a flat base plate. We can make base plates so flat that we don't need any shims at all. But we have to get our manufacturers to do that for us. And that's the bit we're going to have to make sure that they understand what trouble they're causing us. When I buy a new pump in, it's already shimmed up at their workshop. They have given me breakdowns. They've given me a breakdown every now and again for the next 50 years this machine's in service. And they don't see it. And I never saw it until 2 years ago. So it's interesting when you look at the limitations of our materials and what that means in terms of the longevity of our plant.
You know, I just thought it was interesting that if you look at your house, carpenters are master uses of shims. Every footer that goes up to support your frame, you know, some have a shim under it, some don't, some have 3 shims. It's a mishmash.
We've done this because when something's happened and something's gone wrong, I've got to have an answer. I've got to solve this in some way. So we solve it. We will solve our defects, we'll solve our problems, have done for 10,000 years, and we'll do for another 10,000. But the point is you have now got more things to go wrong. And every now and again, the risk situation might arise when that unlucky day it happens to us. It didn't have to happen, but the opportunity is now there that had it been right, there'd be no opportunity to go wrong. But now I've got opportunities in 5 more places, and they are there forevermore, and the day might come against us one time. So we just never know. That's risk. The risk is there. Whether it actually turns into a disaster, never know. May never happen. But the opportunity is there for it to happen.